Hey class, this is the first video of our gas unit, and we're going to talk about Boyle's law, the first and most important law of all. Now, the question says, suppose a gas has a volume of 25 liters and a pressure of 3.2 atm. What would the pressure be if the volume were decreased to 14.6 liters? Now, first off, we have to realize with Boyle's law, temperature is constant. So we're going to make a note. Temperature is constant. Next up, we're going to identify our formula for Boyle's law, and that's going to be P1 times V1 equals P2 times V2. So the pressure before times the volume before equals the pressure after times the volume after. Now we simply just fill in our variables. So the initial pressure is going to be 3.2 atms. And the initial volume is going to be 25 liters. I usually put these in parentheses where I don't screw them up. That's going to equal our pressure afterwards, which is what we're solving for. So I'm going to put P2 times our volume afterwards, which is 14.6. Now we just solve the algebra. P2 times 14.6 gives us 14.6 P2. And then 3.2 times 25 gives us 80. Now we've done the multiplication, we have to do the division. Divide both sides by 14.6. This side cancels out. You're left with just P2. And then 80 divided by 14.6 gives us 5.4794. And we only had one decimal place in our question, so we're going to round that to one decimal. The 4 is going to go up. We're going to end up with 5.5. And don't forget your units. ATM equals P2. Simple as that. Not nearly as complicated or as tedious as stoichiometry. Next time, we'll look at Charles' law.